Hello everyone! It's another learning day. Again, this is your teacher Marlene Nuno, and I'm going to discuss all about the special right triangle theorems. Let us see why right triangle are special. So before that, let us recall all about the right triangle. So the legs are the sides that include the right angle, and hypotenuse is the side opposite the right angle. Let us have this in our illustration. So this is our triangle A, B, C, and this is a right triangle. So we have a 90-degree angle in our angle B. Then we have AB is one of the legs, and also BC as the other leg. So in between legs AB and BC is our right angle. Then opposite the right angle is our hypotenuse. So remember this because we are going to use these parts in our discussion. Now let us start with the first special right triangle, which is the Isosceles right triangle theorem, or the 45-45-90 right triangle theorem. It describes as the hypotenuse of a 45-45-90 triangle is the square root of 2 times the length of the leg, and each leg is the square root of 2 over 2 times the hypotenuse. To clearly illustrate this, let us have our figure. So we have triangle BCA, wherein angle C is our right angle and it measures 90 degrees. So angle A measures 45 degrees and angle B is also 45 degrees. So the sum of the measures of the three angles is 180. So opposite angle A is our leg BC. Let us represent this as L. The same with the opposite of angle B, which is the leg CA. Let us represent this as L, since the two sides are congruent. So opposite our C is the hypotenuse. Let us represent this as a small c. So C is equal to the square root of 2 times the leg. That is the first one. And the second one is the leg, which is equal to the square root of 2 over 2 times C. So try to remember these two formulas. Now, to clearly understand how we arrive at those formulas, let us have the following proof. So given our triangle ACB, and this is a 45-45-90 triangle, and we have to prove that the hypotenuse C is equal to A times the square root of 2. So let us have our statements and reasons. For statement 1, A is equal to B, and those are the legs of the triangle. The reason? From the definition of isosceles triangle, that the two sides are equal. Then, by using our Pythagorean theorem, that C square is equal to the square of A plus the square of B. Then let us substitute A and B by L. So by substitution in statements 1 and 2. Then combining L squared plus L squared, we will arrive at 2L squared. So after combining and getting the square root of both sides, we will arrive at C is equal to L times the square root of 2. Since L is equal to A, so we can write A times the square root of 2. For the second part, so since we obtained that c is equal to the square root of 2 times the leg, so let us use this idea to find the leg. So first, we're going to divide both sides by the square root of 2 to eliminate the square root of 2 in the right side. So we will arrive at L is equal to C over the square root of 2. Now to eliminate the square root of 2 in the denominator, we have to rationalize by multiplying it to square root of 2 over the square root of 2. So we will arrive at L is equal to C times the square root of 2, which is the square root of 2 times C. And the square root of 2 times the square root of 2 is the square root of 4 or 2. So this is our formula for the leg. Now let us have its application. So find the side of a square if the diagonal is 10 centimeters. Now let us have our illustration of our square. Now let us have, this is our diagonal, which measures 10 centimeters. And of course, we have the 4 sides. And they are equal. So let us represent this as S. Now to find for S, we need to use the idea that in a 45-45-90 triangle, each leg is square root of 2 over 2 times the hypotenuse. So by substitution, L is equal to, or let us use S, is equal to the square root of 2 times C over 2. And let us substitute C, which is 10, and then 10 divided by 2, so we will arrive at 5 times the square root of 2 as the length of the side. So see, if you memorize the formula, we can easily obtain the value. Now let us look at our next application. So find the diagonal of a square if the side is 12 centimeters. Again, let us have our square. So this is our side with 12 centimeters. So actually, we have all the 4 sides is 12 centimeters. Now let us draw our diagonal. And this is our unknown. So we are going to use the idea that in a 45-45-90 triangle, the hypotenuse is square root of 2 times the leg. So by substitution, C is equal to the square root of 2, then our leg is 12. So simplifying, we arrive at C is equal to 12 square root of And we have to prove that C is equal to 2A and B is equal to the square root of 3 times A. Let us draw our equilateral triangle A, B, D. Then since this is equilateral, they are also equiangular. So the measure of angle D that B is equal to the square root of 3 times A. So let us use the Pythagorean theorem that C squared is equal to A squared plus B squared. Then by addition property of equality, we will get B squared is equal to C squared minus A squared. And getting the square root of both sides, we have B is equal to the square root of C squared minus A squared. Now since we obtained that C is equal to twice of A by substitution, so B is equal to the value of C, which is 2A, that is squared minus A squared. So the square of 2A is 4A squared. Then 4A squared minus A squared is the square root of 3A squared. And getting the square root of A squared, which is a perfect square, so we will arrive at B is equal to A times the square root of 3. And this is what we have to prove. So actually this kind of proving is in a mathematical form. That is another way of checking or proving our formula. Now let us have our application. We have to find x and y in our figure. Now let us analyze first the figure. So our given, as we observe, is 60 degrees and opposite this angle is x. So let us call x as the longer leg. And then we have the symbol for 90 degree and opposite this 90 degree is our y, which is the hypotenuse. And obviously, the missing angle is 30 degrees. And opposite this 30 degrees is 8. And this 8 is the shorter leg. So we all know in our previous discussion that the hypotenuse is equal to 2 times the shorter leg. So by substitution, hypotenuse is represented as y, 2 times the shorter leg, which is 8. So we can get y is 16 units. Now let us find our x by using the idea that the longer leg is equal to the square root of 3 times the shorter leg. By substitution, the longer leg is x, and then the square root of 3, and the shorter leg is 8. So we obtain x is equal to 8 times the square root of 3. See how easy if we know the formula? So all of these computations are made easy if you memorize and remember these formulas indicated in its special right triangle. Now it's time for me to check how well do you know. Now refer to the figure and name M, G, and N as shorter leg, longer leg, or hypotenuse. So this is the figure. 30 degrees, 60 degrees, and of course the other one is the 90 degrees. We have N, G, and M. Well, that's all I can share. If you have some questions or clarification, let me know by writing your comment below. And please keep on watching on my YouTube channel, Teacher Marlene Nuno. And do subscribe and hit the notification bell for the updates of my video lesson. So keep on learning. God bless everyone.